This is part 1 of the HP 3D Structured Light Scanner video tutorials. The tutorials will guide you through different steps in using HP's 3D Structured Light Scanners. Part 1 is setup and calibration, Part 2 is scanning, and Part 3 is scan alignment and fusion. These tutorials will feature the HP Pro S3 with the dual camera upgrade kit, HP 3D Scan software, Pro version 5.2.1.1073, the HP Automatic Turntable Pro, and the Desk Scan Lever Pro. In addition, the tutorials reference HP online instructions and other online resources available at HP's website. Part 1. Setup and calibration. Let's start by looking at the work area setup. The scanner is mounted to a workbench covered with a black tablecloth. Generally, a darker room is better for scanning, but the most important factor is that the ambient light is constant during scanning. The scanner is set up with both cameras and the projector mounted to the rail, the turntable connected, and computer is ready to be connected. Let's go over the connections. Be aware that USB bandwidth is a key element to ensure that scan performance is not impacted. It is recommended that both cameras are directly plugged into the computer. The projector goes into the HDMI port. In this setup example, the software USB flash drive, mouse, and turntable are connected to a USB hub, which is then connected to the computer. Further details are available in the HP online instructions. Set up the HP 3D scanner hardware. In addition, the power option on your Windows PC should be set at maximum power performance. Turn on the projector and set the projector as an extended desktop in the Windows operating system. In this setup, a computer using Windows 10 is shown. The correct setting can easily be achieved by pressing the Windows key together with the letter P and selecting Extend. When in extended mode, the computer is display 1, showing live camera views in the software, and the projector is display 2, used for projecting the structured light patterns. And you can download and install the latest HP 3D Scan Pro version. Also, any software update will be prompted upon HP 3D Scan software launch. Further details are available in the 8 flash drive. For the software to run in fully licensed mode, the USB flash drive must always be plugged in before launching the application, even when the software is installed on the computer hard drive. Focusing on basic navigation, you will see 3 tabs: Setup, Scanning, and Shape Fusion. Let's start with the Setup tab. On the left-hand side, select Setup Type, Pro S3 for this setup. Connect turntable, check. Projector, 1280 by 800 pixels for this setup. Frame rate limit, none. And cameras, 2 Cam Pro 2.3 megapixel for this setup, and both buttons set to on. Calibration scale will be discussed shortly. On the right side, you will see the live preview camera views and exposure and brightness sliders. The center window is the scan working area and shows either the live camera view or the 3D scan result. Prior to the calibration and scanning, it is important to position and focus the projector properly and set the correct focus and aperture for the cameras. Further details are available in the HP online instructions. Perform the initial hardware setup in the HP 3D Scan software. Note that the more precise the settings are, the better the scan results will be. Today we're going to be scanning a small sump pump with varying colors and surface textures, as well as the strainer base for the pump, which also has some different coloring and other features which are important. Start the setup by placing the scanner in front of the object to be scanned and aim the projector so that it illuminates the surface. Make sure the entire object is illuminated, but as little as possible of the area around the object. Adjust the projector focus using the lever on top of the projector so that the projected stripes are perfectly focused on the object surface. When using one camera, the rotation angle for the camera should be set at approximately 22 degrees, with the camera usually mounted on the left side of the projector. A slightly smaller angle between 10 and 20 degrees can be used when using two cameras. For optimal results, use the same angle for both cameras. For this setup, the projector is positioned near the center of the rail, preferred for dual camera. Both cameras are set at 15-degree angle. Angles should be adjusted and be further optimized for the object that is being scanned. Once the camera angles are set, move the camera sliders so that the cameras are aimed on the projected pattern on the object when viewed through the live camera windows in the software. The projected patterns on the object should be visible in the center of the screen, as well as the preview images on the right-hand side. Slide camera position on the rail as necessary to get the correct view. Now let's work on the mechanical settings, focus and aperture of the cameras. When using two cameras, start by selecting the preview image on the right-hand side of the software that corresponds to the camera you wish to adjust. Notice that there are set screws on the camera focus and aperture rings. Focus the camera by loosening the lens screw for the front ring of the camera and adjust the ring until the image of the scan object is as sharp as possible. This process can be made easier by initially setting the camera aperture open too much using the back ring of the lens so that the image is very bright, and then zoom in on the computer screen. This will make the image on the screen much more sensitive to changes in the camera focus and make it far easier to focus the scanner correctly. Once you have got focus sharp, lock the front focus ring on the camera lens. Click on the Auto Adjust Eye button in the computer software to zoom the image back out again, and then move on to setting the aperture. The aperture should be set when the brightness slider in the projector control setting of the software is at its maximum setting. Adjust the back ring of the camera lens so that the image is clear, but not so bright that the red sine curve is cropped by the blue lines. With the aperture set correctly, the amount of red areas showing on the object in the preview image will also be minimized. Further details are available in Step 9 of the HP online instruction. Perform the initial hardware setup in the HP 3D Scan software for further information. Once the aperture is set, lock the rear aperture ring on the camera. Using dual cameras, select the preview image for the second camera and repeat the focus and aperture setting process. The scanner is now ready to be calibrated. Spending time on getting good at this step will yield great scanning results. Further details are available in the HP Online instruction, Calibrate the Scanner. Remove the turntable and object and place an X on the work surface using painter's tape or some other marker in the center of where the turntable was positioned. This will help keep the calibration at roughly the same distance from the scanner as was the object during setup. Choose the calibration scale that fits the object you are scanning. For this object, the 120 mm calibration scale will be used. Set the calibration panel in place. Most of the time, you will need to do some minor repositioning of the scanner to get a good calibration. Moving the scanner vertically or horizontally to maximize the light pattern on the panel will be helpful. Avoid changing the distance between the scanner and the panel, however. You must be able to see all 6 rings and 15 to 70 calibration markers in both camera view windows. The cameras and projector should not look at too flat an angle, and the camera views should not extend aside the panel. When using dual camera setups, the rings and other points must be visible to both cameras at the same time. Move and twist the panel to ensure rings and calibration points are properly oriented. Look at the camera view windows in the software. Make sure the pattern is visible, clear, and focused. Look at the red intensity sine waves on the image and adjust the brightness slider in the software to assure that the sine waves fit well within the pattern lines. Do not change the mechanical settings on the projector or cameras. Click the calibration button. After a successful calibration, the image will change to a checkerboard pattern. Further details are available in the HP Online Instructions, Calibrate the Scanner. You can now move, rotate, or tilt the scanner assembly without losing the calibration setting. Powering down the equipment and closing the software program will not change the calibration. This ends part 1 of the tutorial, Setup and Calibration. In part 2, scanning will be demonstrated.